Yes, dear students, last class we have discussed about the introduction of MapReduce, Hive and also Pick. So today's class we are discussing about the MapReduce map task, reduce task and the MapReduce execution. So in this big data processing employs the MapReduce programming model where a job means a MapReduce program, each job consisting of several smaller units from the input. That we are calling it as a map reduce task. And here we are going to discuss about the software execution framework in a map reduce programming where it defines the parallel task, and this shows the MapReduce programming model where it implements the Java framework on the Hadoop MapReduce, and it will be consisting of the input data and the output data. In between the input data and the output data, it will be having the important tasks that we are calling it as a map tasks, and this map task will produce the output for each and every smaller unit of a map. Then it will be storing that output in the reduce task, and this map and the reduce task together we are calling it as a map reduce programming model. So let us see how this is working in functional way in the map reduce programming model. So here we will be taking many of the real world situations which are expressible using this particular map reduce programming model. Here we will have inner join, data center, key space, indexing to a field. So these are the terms we are discussing related to our map reduce programming model. The inner join says that the default natural join. However, we have seen the information about the natural join in the previous classes as like a DBMS. It will be consisting the inner join, and it refers the two tables that join based on a common columns which is mentioned using the on clause of the DBMS, and inner join returns the all rows from both the tables in the column matches. See, this is the input. However, this has been splitted over the map 1, map 2 and the map 3 tasks, and this output will be coming and joining at the inner join and storing the output of all the map tasks in the reduce, and that output will be storing in the output data, and this node refers to a place for storing the data block and also read or write computations we will be having. And data center suggests that it will be consisting of the database where it refers a collection of related nodes, and many nodes form a data center or a rack. So this input is available in our data center, and later it will be having a cluster of information. The cluster of information provides a collection of many nodes. This is our single programming model in our MapReduce. Like this, we will be having different data nodes. The different data nodes will be available in the cluster, and later we'll be having a key space. It means a namespace to a group, multiple column families, especially one per partition. See here the partition is of a map 1, map 2 and map 3. For each and every partitions, we will be having a key spaces for every smaller unit. That key space provides us a group of the multiple column families, and it will be providing a namespace to each and every map tasks. And last, the input data is going to be available in the input form where it will be stored already in the HDFS file, and the output task is also going to be stored in the HDFS files. So from wherever I got the same space, it will be available our output data, and the compute nodes and the storage nodes are same at the same cluster. As I told, it will be of a one cluster of a data from where I receive the data as the input, and from where I will be getting the output, and where I will be storing the output, that is in the same cluster. So MapReduce program and HDFS are running on the same set of nodes. This is how about the map reduce map task as well as the reduce task. And let us see further whenever it is going to submit the process on a client. It means the job or a job is going to be submitted on the map reduce process, then how the map reduce and the map task as well as the master job tracker are providing the task trackers and the trackers. Later we are getting the output on the reduced task, and also the final output is available. So let us see what is a job tracker and the task tracker. So job tracker. See here in this diagrammatic representation, we have a client job, and this is a master job tracker, and map task we will be having, and the input files where it is being stored from the HDFS file, and each and every map task is going to have a data segment and the mapping output. That mapping output of each unit will be storing in the reduced task, where it will be having a task tracker. Then the final output is going to be stored in the final output that will be available in the HDFS file. So here the job tracker and the task tracker. Job tracker as well as a task tracker consist of a single master, where job tracker and a one slave task tracker. See, this is our job tracker, and the one slave task tracker will be available per cluster node. See, this is a one cluster node, this is the second cluster node, third cluster node. So from the master job tracker, the job will be assigning to the map task, and this map task implements a map function which runs user application codes for each key value pair of a data, such as k1 for a key 1 and value 1 for the value 1, where k1 is a set of keys and k1 maps a group of data values, and that are having a large string which is reading from the input files, which will be reading from the input files, and that data will be available in the map task tracker 1, and it will be taking the data segment. So that data segment will be taking the information from the map task 1. After mapping the key value pair by using a map function, later it will be consisting of the map output that will be storing in our reduced task. So this reduced task receive the output from this map is in terms of the key value pair. As like how the map function receives the input, the output will also be available in the same format, and the value is having the information for the transformation operation at the reduced task by using aggregation or the other reducing functions, then that will be storing as a output in the final output. So this is how the map reduce is going to process on the client submitting job. And next we will be having logical view of a functioning of a map. In this logical view of functioning of a map, Hadoop, it is been used with a Hadoop where the Java application programming interfaces includes this map function, and an abstract function of a map is present the mapper class. Okay, and any of the specific mapper implementation should be a subclass of the class where it overrides the abstract function. And one more information here, whatever the input is available in the form of a key value pair, the map function will be having key 1 and the value 1 till the next list, where the next list will be consisting of a k2 and the value 2, where it represents when it requires the intermediate output, which is in the form of a key value pair. And if you are not having the output from the previous map task, then it will be proceeding with the intermediate output which has a key value pair as a output in the next logical way of a function. And next we will be having a key value pairing in a map radius. Here I have a data input which is stored on a hdfs, and we will be having a input format. The input format may be of any data. It is like a structured data, unstructured data, semi-structured data, and other information. So only we are mentioning here input data formats, and this input will be splitting in terms of the input split, and that input split will be in the user or the programmer's weave. Here we have a three input splits. In this three input splits, it will be using the function unit called as a record reader. So this record reader will be accessing the information conversion from a text format to the key value pair, because I am providing the input from the HDFS to the map task. It will not be available in the key value pair. Henceforth, I will be using a record reader where it functions for the conversion of a text format of a data into the key value pair. Then that will be provided to the map task where it uses the map function of the logical way. Same way, it will be producing with the input split second, input split third, so on up to the n key value pairing in the map reduce function. And next, we will be having a grouping by key, partitioning, combiners, reduce task, details of a map reduce processing steps, and coping with a node failures. We will discuss these topics in the next class. Thank you, dear students, for the attending of the session.